All right, hey everyone. We're going to work on building a simple Farcaster V2 swap frame from scratch. Goal here is to start with the Farcaster V2 frames demo repo and build out, I guess, over the next hour, maybe 2 hours, as much of a really simple basic swap frame as we can from the ground up. Yeah, I'm a huge boomer. Who's bad at computers. But yeah, I think the chat is on if folks want to have questions, or if you want to ping me on on Farcaster as we go, um, or just follow along. And cool, yeah, let's get started. Okay, so over here I've grabbed the Farcaster Frames V2 demo repo, and we're just starting with this as like the basic scaffolding for our new app. The whole purpose of this repo and goal with this repo is that you can grab this, clone it down, and use it as the basis for your own app if you're building a Farcaster V2 frame. So this demo app that's over here is this demo app running in my local iPhone. Actually, I found, so Steve, I think, on Farcaster shared this recently, but this new iPhone mirroring feature is great for Frames V2 development, where right now the frame dev tools are on your phone. So this is a really useful new tool. If folks haven't checked this out yet, this iPhone mirroring tool where it'll actually connect to your actual phone. So have been using this pretty extensively for frame testing. But yeah, here we go. We have like the sort of basic default demo app set up over here. And if you've watched the earlier tutorials that I did, maybe you've seen this app before. This is just kind of demonstrating the basic features of Frame V2. So we can see like the user context. We can trigger different actions and things in here, close the frame. So this gives us a nice scaffolding to get started today, build out like a more functional example of a real world app. But we can start, yeah, just start here. So we're going to start by kind of clearing out the internals of this frame, and then we'll add our own basic swap interface and stuff over in here. Yeah, let's just talk a little bit about what I want to do here. So goal here is to build like a really simple swap frame. This sounds maybe like one of the most basic things you can do in crypto, right? Just swap one token for another. But I think this actually hides a lot of complexity when you start thinking about breaking down what we want to build here. So you've probably seen this before, right? Maybe we've gone to like app.uniswap. Surely you've seen like a swap frame like this before, right? You enter in some amount of ETH that you want to trade for some token, USDC, USDT. You get a quote here, the amount of one token that you'll swap for another. Usually this is two ways. You can switch between them. There's some gas configuration, some sort of minimum price quote, these kind of things. In Uniswap, you can do other stuff in here like limits and buy orders, more complex types of order types and interactions. Today, we want to build just like kind of the simplest possible swap frame that we can. So yeah, it looks probably something like this. I think it should show the connected address. This is something we have access to inside the, I guess it's not in the context here, but this is something we have access to inside the frame. Swap one token for another token. Usually you'll see, you'll enter some amount up here. We'll do some price conversion to the amount that you're getting back over here. A button down here that kind of walks you through this workflow of swapping one token for another. Yeah, this seems pretty straightforward, but when you start to think about it, there's a lot going on here, right? Maybe you have this two-way thing, right? Where you have sort of two-way interactivity, one token for another, switching between the maker and taker side of this swap or this trade. We have all the complexity of token metadata, right? Token tickers, token images, token decimals, especially when you're working with the ERC20s. Maybe we have multiple chains. We have getting a quote. We have statefulness, right? Things that can change on chain between the time that you get a quote and you actually execute the transaction. So error handling, things like this. This is actually like under the hood, quite a complicated component to build. So let's make some simplifying assumptions. How do we do this? yeah, we'll make some simplifying assumptions just to make sure we can get this shipped and make this as simple as possible today. So we'll just use base. So we'll just use no mainnet, no multi-chain. We're just going to connect to base today. We'll just swap native ETH. So of course, usually you can do ERC20 to ERC20 token swaps. In that kind of situation, you'll need to deal with things like token approvals and permits, use signatures, and stuff like that. Native ETH is really simple, so we're just going to swap native ETH. Let's just go one way. So we will just swap native ETH for token. And in fact, let's just start with like a single hard-coded token, USDC. Kind of boring, but good, simple example. And yeah, I think that's a good place to start. I guess the other thing is we'll use the 0x API. So there's a great example of like a simple Next.js swap already. The folks at 0x have built this swap demo tutorial. You can find in their docs examples of a bunch of different tools in here for building a swap. Somewhere else in here there is a written tutorial. Anyways, we're going to use this as the basis for our example today. So basically, take some inspiration from this repo, but drop it into our Frame V2 app. If you haven't used 0x before, maybe you've worked with a DEX directly, right? Like worked with Uniswap. 0x is an API offering. It's a service that kind of abstracts over multiple on-chain liquidity providers if you're doing a swap. So they provide a nice set of APIs where you can make a request with token swap configuration and get back from 0x. They sort of abstract over multiple different sources of on-chain liquidity. So that might be, on base, that might be Uniswap and Aerodrome and a bunch of other sort of long tail liquidity providers. You give them basically the token parameters that you want over an API. They'll give you a price quote, and then you ultimately send back transaction call data that you can use to make the swap. So it's a nice service that abstracts a lot of dealing with the kind of lower level on-chain liquidity and swap providers. Maybe if you've worked with Uniswap before, difference if you're directly integrating with Uniswap would be that you would like interact with the Uniswap contracts, right? To get read the contracts to get a price quote, use some of the like periphery contracts in Uniswap to do your price calculations. You can think of 0x as like a layer on top of that, on top of multiple different dexes, where they're going to go aggregate liquidity across these multiple dexes, give us back a price quote that we can use. And nice thing about that is that they basically give us back swap transaction call data, which we can pass directly to a hook like WAGMI or whatever tool we're using to execute a transaction. Sort of just take that back, pass it directly to the wallet to execute. So it's a really easy way to get started with building a swap. And goal today is demo building something sort of sufficiently complex to be a little bit bigger than the demo app, and actually interacting with the user's wallet. So it's going to provide us kind of a nice way to get started. Okay, those are the goals. I've worked a few steps ahead, and we have a example repo we can crib from if we get stuck. But yeah, here we go. Let's do it. This is not the repo I was looking at before. Let me go find it. Okay, cool. Yeah, here's the written demo documentation if you want to go check this out separately. I think I linked this on Farcaster too when I was posting the live stream notes. And we'll grab, here we go. Here's their demo code repo. So we can crib a bit from this as we build our app. Okay, cool. If you want to get started and follow along, by the way, you can grab this Frames v2 demo repo. Just clone this from Farcaster XYZ Frames v2 demo. Yeah, and we're gonna start from exactly where the last commit on top of this repo right now. Okay, cool. So I'm set up over here. This is like kind of my local Frames v2 dev setup that I've landed on so far. We have a couple things going on. I've got this split terminal down here running the local dev server. It's just the Next.js dev server. And then in the like local testing environment, you need to tunnel a connection to your local dev server. So doing that over here with a simple ngrok tunnel. This iPhone mirroring app is pretty slick. It's really nice because you can then just copy paste data, especially these like tunnel URLs, right into the dev playgrounds. If you're looking for this in Warpcast, here's how you can get there. Go to your settings, developer. You may need to turn on developer tools. Toggle this on. Then you'll see developer settings, frames, and this launch frame form in here where you can interact with the frame, testing your frame on Frame DevTools. Okay, so new ngrok URL. It's helpful in here too to put in a splash image and splash background. Let's use F7, F7, F7. And I'm just gonna use the demo image. I think this is it. Yeah, there we go. So this will load and you can get away with it if you don't put your splash image and background color in there. But it's a lot nicer, especially if you're debugging, to tell, is my app actually running? If you put this in, you can tell versus just having a blank white screen. So a couple common things that can happen here, by the way. The biggest issue we've seen new frame devs run into just when they're getting started is issues with their tunneling tool. Especially if you're using the free tier of ngrok, it puts this interstitial between your tunnel and request into your local dev server on the first request. So usually if you're accessing that in a browser, you can click through this interstitial and say like, yes, proceed. This is like a abuse prevention tool. But we found that in this launcher, right, there's no way to click through this interstitial. So there are like configuration things you can do in ngrok. If you upgrade from the free tier to ngrok, or if you set specific headers, you can bypass that modal. There are ways to do this, but it's tricky out of the box, especially with this tool. And folks who are just getting started sometimes see their app just hang forever. So the one tip I have here is to watch the logs here in your tunneling tool and your dev server. And so like the thing to watch for if something is in between is just to watch for requests that actually come all the way through to your local dev server. So you should see one here when we load it. Yeah, there we go. So in my server logs, we saw like an actual request come through. If your app is just hanging here, right, and maybe you're seeing requests come in to your tunnel, but not to your dev server, that's an indication that that interstitial is popping up, and you should go check out your tunnel configuration. The other way around this is just not use ngrok, use another tool. So Tailscale Funnel, I think a lot of people have recommended. There's a Cloudflare offering. There are a bunch of other offerings for tunnels. So okay, that's a quick tip there. All right, let's actually do this. So we have in sort of the layout of our app here, I'm not gonna touch much of the demo app here, but we just have this single component. Let's look at the layout. Our home page renders this app component. This app component renders this demo component. We have a little bit of indirection happening here because we're importing this dynamically, which is sort of implementation detail of the way that the SDK is implemented right now. So we need to import these dynamically. Working on improving the SDK, so maybe this isn't necessary. But yeah, then this app imports this demo component, which is kind of the core of our application. And so we'll just work in here as the core of our swap application as well. So let's just get rid of most of this. We're not going to need it. Just put some placeholder in here for now. Cool. Get rid of all this demo specific stuff. I'm going to leave like the very most basic part of a frame v2 frame in here, which is just loading the context and calling ready on the SDK. But we can get rid of everything else. Oh, 20 messages in chat. Nice. Okay. Oh, cool. We're so back. All right. I'm going to catch up on these chat questions. GM. Do I strictly use Excalidraw for my pre-frame planning? No. I love Excalidraw though. Probably a single pool to start. Yeah, Royal, we're gonna like simplify this. I think let's just start with like native ETH to USDC. I think will be the simplest thing we can start with. That's as far as I got in the version I speed ran earlier. Dealing with vol is complicated. Yep. Is the video recorded? Yes, I'm recording. Does Matcha use 0x? Yeah, Matcha is 0x. And how is the app preview on the right being shown? Specific program? Yeah, it's iPhone mirroring, which I think is just on the latest version of iOS and macOS. Okay, cool. Caught up. I'm watching this now, so if folks wanna ask questions in the chat, I'll keep an eye on that. Okay, so this is like the most minimal possible frame component we can have here. Basically, we have this effect when it renders. We call this ready function from the frame SDK. This is what hides the splash screen and designates that our app is ready to go. Let's rename this swap, I guess. Why not? Cool. And let's see, we're not even really using the context here. So let's get rid of that too until we need it. Awesome. Okay, I'm feeling lazy. I'm going to use cursor to give us a basic swap layout. Let's see how this goes. Let's add basic UI for a token swap interface. Don't wire it up to anything right now. Just help me create the UI components. Let's keep it all in this swap.tsx file. It should show, whoops. The user's connected wallet address. An input field for buy token. A button to execute the swap. Drop downs with token, image, and ticker inside the inputs. All right. This worked pretty well the first time. Let's see what it comes up with now. Yeah, this looks fine. Let's roll with it. We need to create this swap input component too. Let's just inline this. Keep this simple. Okay, perils of this approach, I guess, are that it produces a lot of a lot of code, but I think this is pretty straightforward. Great, thanks, buddy. Yeah, not bad. All right, let's edit this a bit. Okay, so rather than using this connected address, let's go ahead and use a wagme hook to get this. And because we're using the demo app, this is like already wired up to a wagme provider. So we have this configured to connect to base. We're using this frame connector, which is part of the demo repo, to connect up to the wallet that's provided by the SDK. So that stuff is all set up. We can just start directly using these wagme hooks. So let's do that. Cool. Awesome. Yeah, and this is my actual connected wallet address here, which is great. So yeah, we're actually connecting up to um, my connected wallet, which has been injected into the frame context. Cool. All right, this is kind of stupid. Let's go to that. And we'll just conditionally render this bit in case there's no address. Okay, a little bit of funkiness going on in the styling here. Can I? Yeah, there we go. Let's see what else. We also have these mock tokens. Yeah, that's fine. Let's change these tokens though, just to tokens. And I think we're going to want some more information in here. I know we're going to want decimals. So ETH has 18, USDC famously has 6. These images are wrong. I'm going to go crib from our other demo here a bit. Yeah, in fact, just to speed this up, let's go ahead and do that. So we'll define an interface that represents a token. It's got a symbol, name, image, address, and decimals. Since we're going to be swapping from ETH to USDC, like we'll pull out ETH here. Claude did better the first time and came up with these images, which actually work. The 0x API uses this special address. I call this the dolphin address for ETH. So it's all E's, 0x E. You might also see sometimes like the 0 address is used to represent Ether. I like the dolphin address better in applications and contracts that you use it because the 0 address often also indicates like 0. And Solidity has default values for the default value for an empty address, right, is all zeros. So better to use this like special sentinel address that indicates this is ETH. Okay, let's grab these guys. And yeah, let's update. Let's add a couple more use states in here. Okay. Okay. Getting closer. All right, let's just like walk through what I've copy pasted here. Okay, so key things we need to like hold on into this component state, right, are which token we're selling and the amount that we're selling. So we're just going to hard code the sell token always ETH with these attributes up here. We're going to read this amount out of the input, so users can type in some amount. We'll hold on to that statefully. We're going to calculate a buy amount based on the data we get back from this API. And maybe we want to abstract this. Maybe we want to introduce more tokens, right? For now, we're just going to use, only USDC in here, or we could go load this, at some point from a list of tokens with all these attributes. But like for this demo, we'll just have a list of tokens, so we can maybe expand on it. That can be an exercise to folks who want to build that after the stream. But for now, we'll just put USDC in here. So okay, and then down here in our actual UI components, we have this cell input. We've got an input element. So one thing that's helpful here, I've noticed some folks in frames that have been built already. If you don't specify an input mode, there's a special attribute you can put on input components. If you don't specify an input mode on mobile, you're going to get like the default alphanumeric alphabetical keyboard. When you're using numeric inputs in like a swap frame or something like this, make sure you set this input mode. You can do like decimal or numeric for a numeric input. In a swap, you probably want decimal here, which gives you the like numeric keypad with a decimal place on it. But there are other options for like the phone keypad and the alphanumeric keypad and all of this. But it just makes it like one step easier for users to interact with the frame, especially since these are mobile only right now and mobile first always. Make sure you specify these so you get a nice keyboard for the user in mobile. Okay, so yeah, this input, we're going to pass through the sell amount value. Keep that updated, right? As this input changes, set that amount in state. We'll put an image inside it here with the token image and symbol. And then on the buy side, a little bit more complicated because we have an actual dropdown in here. Same thing, buy amount. We're going to keep updated as we change. We actually probably shouldn't even do this because we're just going one way, right? So we're just gonna always calculate this value. Maybe if we get far enough, we'll make these two-way. But whatever, I'll just leave that for now. Got our token image. And then within this, we actually have a drop-down selector where we can choose another. So we'll just have one option in there for now, but theoretically we can change this. So value of that drop-down will be the token symbol. When it changes, we'll go find that symbol out of this list of tokens and set that as the current buy token. Okay, we're getting an error here because I haven't updated the next config to allow list these images. So let's do that. Great. Nice. Okay, that looks great. Okay, cool. So yeah, we can enter an amount in here. This is going to be fixed to always ETH. We can choose from this drop down here. If we were to add other tokens, we could switch between them. Cool. All right, catching up on questions here. Destiner asks, wouldn't it be easier to test in the web browser while you're making the app and do the final checks in the Warpcast playgrounds? The answer is no right now because we're not injecting the frame SDK context into the browser. We should probably build some tooling that makes that easier because I think in the long term, yes, that might be a better way to do this. In fact, let's go look at like what happens in the browser. You can actually like pretty nicely prototype your UI elements and stuff. But yeah, here's an example, right? You can see my connected addresses up here at the top in the DevTools, but in the browser, it's not connected. And we have some errors here that are related, I'm sure, to not having that SDK context. So it might be a good idea for us to create like the ability to have a mock context or something in here so you could kind of do more in the browser. But yeah, right now it's easier to use the DevTools. Okay. All right, let's get rid of cool USD coin and keep going. I'm gonna change these to sell token. We have that hard coded to ETH, but in case we ever change this, that'll make this a little bit more flexible. Okay, cool. And this button just does nothing. Let's see. On click, do nothing. Great. Okay. So let's implement the actual swap logic. In the 0x context, there are 2 steps to this. And if you walk through this demo tutorial does a nice job of explaining it. But basically, there are 2 steps here. The first step is basically getting a representative price from the API, which is not like a finalized quote, but is kind of just a quick endpoint that returns the anticipated price. And then once you have that price, usually typically in a swap, you display this to the user. This price can change, right? Like I don't think we're gonna get as far as building in really good, robust like price handling here today, but like you probably want to reload that price every block, or depending on I guess it depends on the chain you're working on, but like on some regular interval, make sure that you're refreshing and getting a fresh price because prices change, right? Especially I guess we're swapping ETH for USDC here, so hopefully that won't be too bad. But right, if you're building like a clinker swap frame or something, right, those prices are super volatile. You need to deal with handling all the error conditions that can come from stale price and changing prices and slippage and all that stuff on chain. So sort of the more volatile your token, the more you need to keep up to date with price. And then there's a second endpoint here that actually returns a quote, which is like a finalized quote and the call data for actually executing that on chain, which is a little more of like a heavyweight endpoint. It does more computation, and so ideally you call that less. You show the user this representative price. They kind of say yes, this price looks good. Then you finalize it, get a final quote, and typically will show here's like the minimum amount out that you'll get from this swap. So there's this 2-step process where first we fetch the price, and then second we finalize and actually execute the transaction. So we're going to hit two different 0x APIs. One is this price API swap permit to price, and one is this quote API swap permit to quote. Okay, so yeah, let's go look at, it's not crib from my my homework, which was already done. Let's go look at this 0x example. So they're doing this with two components. I'm going to cram it all into one component in our example here. Probably good practice to split these up across a couple of components, but just for time's sake, we're going to put these all in one. And let's look at what this is doing to get the price. So yeah, this is pretty similar design to what we're doing, right? You have the sell token, the buy token, sell amount, buy amount. This has a trade direction. We're not going to worry about that because we're simplifying to just go in one direction. They're handling tokens that have buy and sell taxes. This is another complexity that we're not going to deal with today. Here, if we were to abstract ours to have more than one token, more than USDC, maybe we would do something like this, a long list of tokens by symbol. In fact, yeah, maybe let's shoot for that stretch goal. Okay, and here's where the sort of price fetching is happening, right, in this effect. So it's going to fire this effect. We're building up a parameters object here with all the details about the swap. Hit this API route and get back information about the price. And then this is like parameterized by a bunch of dependencies here. So we're going to fire this request every time one of these things changes. So let's just do exactly the same thing. Pop over to our component. And we need to adapt this to our own code here a bit. So chain ID is just going to be base 8453. It spells BASE in lead. Sell token and buy token. What do we call these? Sell token and buy token. Okay. So I think we have those already. Parsed sell amount and parsed buy amount. Yeah, let's just use sell amount and buy amount right now, but I think we are going to need to parse these. Okay, taker. You'll see maker and taker as like the sides of a trade in a swap frequently. Taker is the person who is buying the tokens. So in this case, this is going to be the connected address. Yeah, JP, good question. When you're running ngrok on the phone, how do you check the console logs of the app? You can't very easily right now. We're probably going to build into the SDK some tooling to make this easier. So maybe we're like, the thinking is that we're going to add like a SDK, I don't know, debug console object that you can call like just like a conventional console.log. And then we'll log that out somewhere that you can go see in the dev tools, which will make this a little bit easier. But yeah, right now there's not much you can do there. One thing I have been doing, one like little hack you can do is just do like a, message, set message with a use state. And then just like put this in your component. Put it at the bottom. Let's see, did we render that? There it is. And then you can kind of like log stuff out just by putting it in your app. But yeah, tooling for this will get better, I'm sure. Okay, so taker should just be the connected address. Okay, this is cool. Within 0x, we can specify an affiliate fee, right? So every swap that goes through our API key, we get like some portion of that swap as an affiliate fee and the recipient of those fees. So I'm going to grab those. Let's use a couple of things here. Let's just set the protocol guild address, which I grabbed here, as the affiliate. So we'll send fees from this frame to protocol guild. And this fee is in basis points. So like 100 is 1%. That's pretty high. Let's just set it to like 25 or 20. I don't think anyone's really going to be swapping through our frame. Okay, so let's do this. Protocol guild address will be the fee recipient and the trade surplus recipient. There are two ways you can sort of like monetize a swap. One is to receive a swap fee. The other is to take take surplus on the trade. Not that relevant to us. We'll just set protocol guild for both of these. And then the token, swap fee token, is the buy token. Okay. Do we need to parse these units? Yes, we do. Okay, yeah, so this is what's going to let us enter, 0.01 ETH and then actually convert this to Wei, which this API is expecting. Great. They're using some npm module to stringify these query parameters. Let's just install it. Oh, I guess it's already installed because I did this earlier. Whatever. I'm sure we could all figure out how to do that without a dependency, but whatever. Okay, so we're going to hit this API, basically stringify this big parameters object into a bunch of URL query params, hit it with, hit this URL, get back some JSON, and then handle the response data. So, okay, some error handling. Let's do this too. Let's call this get price error. Looks like this is an array, probably of strings. Okay, so if this comes back with errors, we set the errors. If we have a buy amount, we got a successful price. And yeah, hold on to this data statefully. Set token tax information. Okay, let's get rid of that. We're not going to deal with token taxes right now. Okay, format units. We need this from VM. Recursive parse units. And sure, set price. Great. Oh, this is my demo. Let's look at the 0x demo. Okay, so there are some helpers in here with some types for the API responses. And these are kind of helpful just to look at what the 0x API returns to us. So for a price response, we get an object that looks like this. It gives us back our sell and buy token, our amounts, fees in case there are fees, gas price. The important thing we care about are these buy amounts, right? Which is where it's doing this price conversion of I'm swapping 0.01 ETH, and here's the amount of USDC that we'll get back. Similar type here for the quote response, which we're going to use shortly. So let's grab these so we can type our responses. And let's inline this stuff too. Okay, so this is a big complicated type, but this is what the 0x API response looks like. I think we have, yeah. Let's just make that unknown. We're not going to use too much data actually out of these responses. Okay, so this is a price response type. Great. Okay, yeah, last thing here is I deleted the dependencies, add all the missing dependencies. Sure, that seems good, right? What are we missing? Yeah. Yeah, okay. Great. Okay, one more thing going on here. You might notice this is like a relative URL path. We're not hitting like api.0x.com or wherever that API is. We're loading this from our own API route, right? Our own next API route. And main reason for that is that we want to keep our 0x API key private. So we're just going to hit our own internal API route, which then goes out and like proxies the request to 0x. So we need to add that too. Let's lay this out. So this is /API/price. So we need to create some folders here. with that same structure and a route.tsx here. And you can see, yeah, their project is similarly structured here. We have API, price, and quote. And I think we can just make use of this directly. Let's just grab this. Okay, so our front end component is going to hit this backend next endpoint. And from here, we're going to actually make the request to api0x.org. Same search params that we're passing into the route here. This is like just pretty straightforward, just like proxy of the same request out to 0x. I think I named this not public. This is going to be on the back end. I think I named this 0x API key. Cool. So yeah, just go hit this price endpoint, swap permit to price, and we'll log it out. Since this is a backend route, right, we'll be able to see it in our logs over here, and we'll be able to see a little bit of like what the response data looks like when we hit this endpoint. Okay. Cool. So we've got our price API route. We have our request here. If we did this right, compilers, oh, that's fine. Okay, cool. We have some unused variables, but I think that's all the complaints. All right, let's try this. So if we did this right, this will fire the request, and we'll get back some data. Let's find out. Nice. Okay. Cool. So yeah, we hit this log statement in the API route. Logging out all these encoded parameters. You can just like eyeball these. Let's make sure they look right. But yeah, chain ID is base, cell token dolphin address, buy token is USDC, sell amount some big way value that looks roughly right. Buy amount 3.70. Yeah, let's sanity check that. Let's see. Is 0.01 ETH about 3.70? Yeah. Yeah, ETH is like $3,700 right now. Cool. Taker address. This is my connected wallet address. Swap fee recipient is Protocol Guild. Cool. And we can kind of take a look at the data we get back, right? So we're getting a block number on base, getting back a buy amount. So this is like the quote for this amount of input. Some of this is kind of like just echoed back, right? The buy token is the USDC. Here are the fees. So 0x takes a fee in the output token, and we are taking a fee in this output token as well. If we go crank up our affiliate fee, right? Let's make this like, I don't know, 500. I don't know how high we can go. We should see that go up. Yeah, there we go. We have a much higher fee. And then, yeah, just a bunch of other details about this price response. Some common errors you might see, like you might get liquidity available false. If you have a typo in your token address, for example. Might need to force a re-render here. Yeah, there we go. So here we're like trying to fetch price details for a token that doesn't exist on base, and you'll get much shorter response, liquidity available false. But you can use that flag to check like, was there a route found for swapping this token? Does the token exist? Oh gosh, I think that was a 3. Yeah, cool. Cool. Okay, so swap 0.001 ETH, get back 3.7 USDC. Looks good. And yeah, we're setting this price data and setting the buy amount to this formatted units. Let's actually disable this input, right? We're not going to do, like, it would be nice to make this go 2 ways, right? So we could say, just buy me 10 USDC and it would calculate the amount of ETH, but let's not do that yet. So until we do, let's just disable that in the buy input. So I can't even enter anything in there. Yeah, that's fine. All right, I don't, if that looked nice, it would be nice to just disable that component or just not use an input there because we're not really taking user input, but this is fine. We'll leave it there. Cool. Okay, so yeah, we're calculating the price. Step 2 here is if the price looks good to the user, move on to get a quote. So let's take a look at that components. Let's just call this swap. So yeah, let's see, what are they doing with the price here after this is set? I think in this example, they just have a higher order component that's setting the price. Let's look over here. Yeah, so they're passing down some setters, pass back up that price, pass that price into the price view component here. And they're switching between these two components based on the state. We're just gonna cram this all into one. So let's see what happens to this price once it's passed into this quote view component. And okay, we have some WAGMI hooks for interacting with the wallet. We have another effect that looks pretty similar, firing off, this looks like mostly the same parameters to an API endpoint. We've got some transaction handling stuff here. We got tax token related stuff. Which we will ignore. Fortunately, we're going to ignore all the weird ERC20s that have taxes and fees and unusual decimals, except for 6. Okay, and then some UI stuff here. Okay, here's our button. So when we click the big button at the bottom of this one, we will do a few things here. Okay. Yeah, in fact, let's go look back at the type of this quote response. Bunch of the same attributes here. Token addresses, amounts, gas price, fees, blah, blah, blah. You'll see we now also have this like permit to object, which has some hex in it. We have a transaction object, some token metadata, but there's a little bit more in here. We also have what looks like, ETH transaction parameters, to address, data, value, gas. So yeah, this quote endpoint, we'll take a look in a sec, but this quote endpoint gives back like the actual transaction call data, which we can execute to execute the swap. So we have a bunch of permit to handling stuff in here, which fortunately we can ignore since we're doing native ETH to token swaps only. If you want to enhance this swap component after the stream and build on top of this demo, this is like probably a good little feature to add. But basically the quote endpoint will give you back the permit to data that you need to sign. Permit to being like an alternative to standard ERC20 approvals that uses a typed signature if you're doing an ERC20 to ERC20 swap. And so if you've done a swap before, in the old days, you would do 2 transactions, right? You would send like an approval transaction first and then send your swap transaction. Later, we started using signed messages, right? Signatures for these transactions where you would sign a typed message or sign a message and then submit that with the transaction at the same time to prevent those two separate steps of transaction. Permit to is like sort of the latest evolution of this concept where you sign this specially typed message that grants access to transfer your tokens if you're doing an ERC20 to ERC20 swap. But fortunately, I love using native ETH. It's so easy. We don't have to do any approvals or permits or any signatures there. So we've simplified our lives and we can ignore this stuff. But if we were doing this, you would need to like get that signature first, get the permit to signature data out of this response, pass it to the user's wallet, have them sign that, and then have them execute the swap transaction. But I think what we just care about here is going to be actually none of this stuff in this if block, just this stuff. Passing through all these quote details to send transaction. All right, we can do that. The other component here is this API route, right? So another API route that hits this quote endpoint instead of the price endpoint. Super similar to the one we just did. We're just like, I think this is the only this is the only difference. In my younger days, I would have dried this up. Okay. Quote components, quote folder. Let's also log out the data here, just so we can see what this endpoint is returning. By the way, I guess I didn't walk through this, but I did go set up a 0x account, generated a project in there, got back an API key. That's pretty straightforward. Just go to 0x, sign up, generate a project, grab the API key, and I have that in the .env file here. Cool. Let's do a little copy paste. Maybe we unify this at some point, but oh, actually, no, let's not do copy paste. Nah, let's start with copy paste. I think we can. Okay, and yeah, let's take a look back at how this is working here. Okay, so simpler handling here, we just set this quote object. So let's put this in state. Quote. We'll hit our own quote API. We're not worrying about error handling here. We're just going to set the quote. And there's no conditional here. We just fire it. Fire it whenever. Let's see. So I think we want something in here as well to track whether this is finalized, right? So when they tap swap, we'll say the price is finalized. We're going to go get the quote. And by default, that will be false. Okay. So let's set that when the user clicks the swap button the first time. And we'll fire this effect when that changes. This is a little hairy. I don't like these huge effects, but let's roll with it so we get this API request to fire, and then maybe let's clean it up a little. Okay. All right, so if everything goes well, I'm going to tap this button. It's going to trigger this finalize callback we defined. That's going to set is finalize. That state change is going to trigger this effect, which is going to fire off this API request. And we'll see something down here in the logs. Nice. Cool. Okay, yeah, and you can see this is like a chunkier API response, right? And that's because you have this huge blob of encoded call data, which is the actual transaction. This is the actual trade, right? We could even go look at, let's decode this a little bit, right? We've got the value of the trade, right? And I'm sending 0.001 ETH. We have some suggested gas price and the gas amount that's going to be necessary for this. We have a bunch of encoded call data here. And then we have the destination address for this. You can also see, like, here's a function selector right at the beginning of this call data. Let's look at what that is. Oh, we just need the first 4 bytes. 1FFF99. What is this? 1, 2. Okay, well, whatever. We can also go look at like where this is, right? This is going to say send this transaction to this address on base. I'm curious what this address actually is. If you've used 0x like on mainnet, you might have noticed you often get this address, like this vanity address from 0x that starts with like 0x DeFi coded. But this is not that, so I'm kind of curious what this is. This is some contract on base related to USDC, base settler. Cool. I don't know. Chat if anyone has ideas exactly which liquidity pool this is. But oh, it looks like airdrop. Okay, there we go. Oh no. We have a bunch of different factories and liquidity sources in here. So probably, I don't know, this is probably a 0x contract or something on base. But you can see, yeah, you can see the idea in here, right? Is that 0x will abstract over all these different liquidity sources: Sushi Swap, Solidly, Pancake Swap, Kinetics, Decky Swap, Aerodrome, and basically find a route that's sort of the best execution for this trade. Okay. Yeah, and then the rest of this probably looks pretty similar to the price data that we got back. It's like, yeah, the buy amounts, sell amounts. We probably want to display this amount to the user. So the minimum buy amount, this is like worst case scenario, the maximum slippage. Worst case, this is the minimum amount you'll receive in this swap. And typically you get better execution than that. If you get worse execution, the trade will revert, the transaction will revert. But this is sort of what we want to display in a confirmation, like this is the minimum amount you'll receive. Is that okay to proceed? So we should probably show this in the UI somewhere. Let's do that. Let's see, we're setting our quote, I think. Yep. Okay, let's just drop this in below our. Oh, I think this is nested. Yeah, actually, it's not nested, but it's not in the type. I think these types have changed a little. The API format has changed a bit since this demo was created. that should be in there as a number. Okay, sure. And we need to format this. And this needs to be a big int. Cool. Yes. Okay, probably need better error handling there. If we go back, great. Let's change this to confirm if we're finalized and swap if we're not. And I think we're in the final stretch here. We need to make this send the transaction. We never displayed the errors. Let's do that. We call this get price. Okay, if we get a price error in that initial fetch, we'll display it. I wonder how we can trigger that. Maybe like a really small swap or something. Maybe not. Okay. So tap swap, we get back our quote. All right, now we just need to make that confirm, send the transaction. So let's use some WAGMI hooks for this. We can grab use send transaction, and we'll grab use watch, use wait for transaction receipt. And let's put these in a callback. Okay, and we want to grab this out of our API response here. Let's go crib from the example here. Okay, so I'm going to get rid of chain ID here. Probably long term, you should be specifying chain ID. I've noticed we have some weirdness right now with the current version of the SDK and the way Workcast is handling wallet connections, where actually when you specify chain ID in some circumstances, you'll get a mismatch chain error. So I'm going to remove this from here. And I only found that experimentally earlier this afternoon when we were playing with this. So if you've been seeing, like, from time to time, you might get an error where it says the wallet is connected to chain ID 1, but it's actually connected to base. Actually, this was happening when I was specifying chain ID in here. So that's on us. We will figure this out in Workcast and in later releases of the SDK. But this wallet switching model is like still a little bit in development right now. One thing we are going to work on this week is making wallet switching a lot nicer. I think within Workcast right now, interacting with these WAGMI hooks and switching wallets is pretty difficult. One thing that's hard to do right is get a list of all the available wallets inside your dApp. It's also difficult to prompt the user to switch their connected wallet right now. And so what we are probably going to do this week is build better tools for basically seeing which wallet is currently connected, like into this this frame interface, right? So you sort of have a view right here of like this address is connected right now. So preventing the need for stuff like this, right, where you're showing the user their connected address inside your frame dApp itself, but like we'll just kind of take some of that, put that into the Chrome here, and make it much easier for you to like tap and switch your wallet within Workcast. And we think probably having like more of this managed in Workcast rather than in your app will be a simpler model for app devs. But sit tight because we haven't done that yet. Okay, so let's remove chain ID here. We also don't need to pass this account. We're just going to use whichever account is connected. We know we have a quote. Okay, and yeah, we're just like passing through these transaction parameters that we got back from our quote. So the gas amount, the to address, the data, the value, which in our case we'll be using since we're sending native ETH. Okay, and then let's call this in our button. If we're finalized, we'll call execute swap, and if we're not finalized, we'll call finalize. Let's check which wallet is connected right now. One moment, let's see, where did this go? Great, we're good. Okay. Okay, something's not working here. Let's grab the error out of our hook and see what's happening. Cool. Cool. Okay, there's our swap. Let's look at the details. On the right network, calling that contract we looked at earlier, sending the right amount, receiving what looks like the right amount. Cool. All right, before we push that button, let's add one more thing in here, which is like watching the transaction receipt. We'll just do really basic handling right now. Let's put this up above the errors. Okay, so we'll put a little confirming message in here when we're confirming the transaction, and a link, transaction confirmed, link out to base scan when it's confirmed. We probably should use the open URL action from the Frames SDK here. If we tap this will link us to base scan inside the frame. What we really probably want is to link out. In fact, let's do that. Let's build a callback for that. So we'll call SDK actions open URL. With this. Yeah, don't need to pass that. Okay. And when we click this error message, instead of just an actual link here, we'll use a we'll just throw an on click. Oh, okay. And we need to grab some of these. So hash is confirmed, is confirming. We need to grab these out of our hooks. This is data. Is confirmed, is confirming. I think that's what we wanted. Yeah. I'm gonna go cheat. Let's see. Is loading is success. Okay. Okay, yeah, we might not have a hash. We'll just like do this conditionally. It's kind of sucks, but whatever. Okay, let's try this end to end. Guess we're not using the price at all, except to set the value here, which then gets propagated into the quote. Whatever. Cool. All right, the thrilling conclusion of our swap frame demo. Let's buy 30 cents of USDC. Nice. Receive 36 cents. Jump over to the wallet. Simulation looks good. I don't know what happens here. Oh, cool. All right, that's pretty slick. Cool. Okay, transaction confirmed. And let's tap this and see if we get taken to base scan. Nice. Okay, yeah, let's take a look at this. We should see, there we go. We called this execute function on that contract address that was returned from the quote API. Here's my address as the sender. We sent some ETH. We made the swap. And you can see the fees in here as well, these fee transfers, right? So I got this 37 cents. We sent, what is this, less than a cent to Protocol Guild as the fee recipient. And this is the 0x fee. Cool. Okay, UI leaves a little bit to be desired once we got past the stuff that that I generated to start. But yeah, it's all functional and it all works. Let's put a little padding on that confirmation. All right. Last step here, just to take a quick look at is app looks pretty good, right? I think we've got end to end. I mean, certainly some things we could improve on here, right? Like, I think we have a couple places where we could do better error handling, right? If we go change one of these inputs after we generate our quote, we blow up. Should go handle that. Probably since this is not actually editable, we would want to make this not actually editable. You know, UI. The other thing we mentioned earlier, right, which we probably want to do in here if we're productionizing this component is like a little bit better handling around refreshing the price on a regular interval, maybe depending on the the token as well, depending on how volatile it is. USDC is going to give us probably a pretty stable price, but if it's a clanker token or like a meme coin or something, we want to be refreshing it on a more regular interval. Yeah, so those are a couple things we probably would want to clean up if you're productionizing this swap component. I think I had one more. Whatever, there are others. Yeah, I guess, and then of course building on top of this, right? The other thing we might want to do if we were building this out further, maybe folks we want to run with this demo, go ahead and add these in if you want. But you could add a longer list of tokens, right? So we could enable an overrun. In fact, let's even try this. Let's see if we can do this. We only have USDC. Let's try some other coin. What's a good one? Let's do like, we're on base. Whatever. Let's do yeah. Let's do Clinker. I don't really know the Clinker icon. We'll just grab the. Sure. Why not? There we go. Grab that. Okay, could probably do better state management here, right? We want to clear the state here when we do a new trade. Oh. Okay, blew up, but not for the reason I expected. Image delivery.net. Oof. Okay. Oh yeah. Okay. This is the other thing I was thinking. Yeah, we probably want to debounce the request to the API, right? There's no debouncing in here, right? So like anytime we're changing the amount in here, we're like firing a million API requests. So good practice to like debounce those in your component so that you only like fire them every whatever 200 milliseconds or something. Not gonna do that right now. Ask Claude. Yeah. Okay. Let's try changing this to Clinker. There we go. Swap. Confirm. Cool. Let's do it. That's really cool. Touch ID on the Touch ID on your machine to confirm. Cool. Yeah, I bought $3 of Clinker token, and we donated some to the Protocol Guild. So there you go. Cool. So yeah, if you want to take this and run with this demo, another thing you could add here is the new other things I built out here, right, are better token handling, right? You can load this dynamically or specify specific tokens. but add additional types of tokens you can swap. Maybe make this two-way, right? So I can enter an amount here, and we'll calculate the amount up here, or switch between them. Maybe support non-native assets for the swap, right? So go and implement actually getting the permit to signature and handling that in here as well if you want to swap from ERC20 to ERC20. Yeah, all those would be interesting places to go with this. The other thing I would potentially do, let's just take a quick look at the embed side of this. We haven't really touched that, right? We've just been working in this single app endpoint, which is just like the swap demo is just at the root of our, or the frames demo is just at the root of our application. Let's actually, we have these two tokens, right? So let's do that here. We have USDC and Clanker. So let's make our embeds switch between these two, right? So by default, we'll say if you drop an embed on the default route, just the home route, let's see what this looks like. Yeah, here it is. Let's change this. We'll just do USDC by default. Okay, so what I'm editing here are the Open Graph tags for the home page of our app. And this is where we're defining this FC frame tag. The ones up here are just like default meta tags, default metadata tags for the app. So this will go into meta. This goes into the page title. These Open Graph ones go into Open Graph meta tags. So like OG title, OG description. And then we can also add other tags in here, which get added to the HTML head. And this FC frame is where we're specifying this frame embed. So this stringified JSON data defines our frame embed. And the cool thing about these embeds is you can put these anywhere. You can put these in any URL in your app, right? You can change this metadata here. You can change this metadata here. We're just going to look like when you drop a URL into a Farcaster client, we're going to parse out the tags and see if there's a frame in that URL. And so you can change this configuration to point to different URLs within your app, or do different things if you want here. So, and there are a bunch of ways you can do this, right? Like this is just, we could pass a query parameter here, right? Maybe we make this like token equals USDC, or you could use a route parameter. This is going to define the URL like within the app that we're going to load in this launcher when we pop up the app. But there are a bunch of different ways you can do this, right? It's just a web app, so use a query param, use a route param, do whatever kind of switching you want here. But yeah, we're going to say like we'll just use USDC by default if we hit this homepage frame, and let's test this out. I've been having some trouble with these today, and I had some other people mention they've had trouble with these. I've noticed sometimes maybe I need to actually deploy this to like for sale or a production environment. I guess maybe this is a next. I don't know what this is. Maybe it's a dynamic generation thing, right? Where like we're not finding the tags when we scrape at the time that we expect. I don't know, but we'll try this. Okay, let's also add. Let's just look at this and make sure those tags are in the app. there's our tag. So that should render as a frame if we have um, our JSON content in there, correct? But just to demo this, let's do another thing here. Let's add like two. Oh, good. We have these already. Okay. So I didn't delete these from the example app. We have these like hello frames routes. Let's do some new routes in here. We'll do frames USDC, or let's just add another one, frames slash clanker. All right, let's use route parameters. Swap. Actually, we use that. All right, so let's set up some pages here. How can we do this? We can use a route parameter here. Let's try using a query param, actually. It's going to make this easier. So let's move this up to the top level swap. We'll delete these special routes. And we'll just do this. Okay, or actually, what I think we want to do is move this into our generate metadata. Yeah, here we go. And then we'll get the params out of here. My next ignorance is showing. Who needs docs anymore? Yeah. Sure. Yeah, I'm on the wrong page. But this is going to be about token search params. Yeah. Someone's probably, yeah, maybe. Okay. Okay, what's going on here? We're destructuring this. It's a promise though. Yeah, okay. Okay, I think that'll work. Fortunately, we can try it on web frames. Brutal. Yeah. All right, still got it. Yeah, we're missing some environment variables locally for the absolute URL to the app, but we'll have those defined defined otherwise. And actually, that might be why. Okay, actually, that's probably why this is failing. Need to edit my .env. Okay, anyways, this should be setting this, and we can update our, let's just pass this through on these two routes. Yeah, so we'll pass through a token. Need to pass this down to the app. And from the app to the swap. Okay, and we'll just quickly switch here. We'll do the exceptional case here. If it's Clanker, and if it's anything else, we'll use USDC. By default, we will pass USDC. And we need to do the same Same thing here. Okay. All right, let's see if that worked. I expect this will show USDC by default. If I go here, frames, and if we do clanker, hey, cool. Okay, switches to clanker. If we do whatever, die, something else, anything else, it'll just be USDC. Cool. Okay, so we can use these routes, right? We have an embed defined at this route, and this will point over here to this frame URL in our app. So that should let us dynamically switch the token here, and we can put a different embed here. Last thing here, let's add an Open Graph image. Let's see if we can get this gone. So I think exact same pattern here. We're going to get search parameters. And then okay, let's test that out in the browser. This might not play well with this magic Open Graph image stuff. I think it might not. Okay, that kind of sucks. We'll just back that up. That's fine. We'll just make this say like swap frame, but we should still get the button to render something different as long as we change the button text in here, which I think we did. No, we didn't, but we can. Okay, we're over my 0x rate limit. Maybe some of you have been trying this out. Okay, I think that's fine. Let's leave that here for now. Let's try and push this up and just see if we can get those embeds to show now. And in fact, let's do this. I'm going to save this. I have the other app pushed up. I guess we didn't add the second token, but yeah, we can do that. Let's move this stuff over to the other app, and then we'll push it up and see if we can get the embeds running, and then we'll leave it there. Okay, so we'll add Clanker. Right. Cool. This other branch had some slightly different stuff in here, right? We had little loading spinner and stuff. Okay. Let's move over these embeds. Oh, I deleted the frame stuff. That's fine. We'll just create a new swap directory in here. Hey, there we go. What did we add in here? No. Okay, yeah, we need to pass through this token. All right. Cool. Yeah, so here's an example basically of how we can pass a query param, or we can use a rep parameter, whatever, to the frame in order to parameterize it by some URL or configure it in some different way, right? So if we wanted a separate frame for every single token address, or every, for a particular username or something like that, you can parameterize them in this way. And we should have separate embeds that are pointing to these URLs at these different routes. Okay, let's push this up and see if we can get this working. Oh, this is no more swap. Just swap. Yeah, still having trouble rendering those embeds. Let's make sure. Let's make sure we're at least serving an image. Yeah. Okay. Okay, I'm gonna push that up. That should deploy to Vercel. Let me go check on it. Okay, yeah, well, we wait. Let's see. All right, so that deployed to production. Oh, nice. You can see much faster, much faster when we're not going through the tunnel. We should be able to load this at /swap. Choose a token, default token. Okay. Okay, there's our open graph. It seems we're still having trouble with the embed. I saw a couple people report this morning, and I haven't had time today to go look into it. So it's very possible something has changed here today. Um, so if it's not immediately obvious, I'm going to give up. But you can go see my earlier demos for how you can configure these embeds. Let me make sure I have well-formed data in that embed route. That is the one thing that comes to mind here. Yeah, I don't think this is it, but let's find out. I don't think I have my don't have my app URL environment variable correctly set on this domain. And sorry, I should show you, but you can tell here when I go look at the meta tags here, these are not valid URLs. And this is on our agenda too. We're going to put better better validation in here on frame embeds. So you'll get meaningful error messages that say, hey, you're missing this value that we expect. Okay, let's go add that and see if that fixes that. What is that called? Next public URL. All right, coming up on 2.5 hours. So we're gonna try this next one, and if it doesn't work, we're gonna call it there. But yeah, if folks are still around, if anyone's still in the chat or watching, happy to take questions before we wrap up. To kind of just narrate over what we did once more, we took the Farcaster Frames v2 default demo app, just use that as our app scaffolding. Most of the work we did was just sort of editing the center of the app, this like demo components. In a more complex frame, you probably want multiple components. We're kind of just working in this single big component in the center. Let's pop it up in here. Built out this simple UI for swapping native ETH to one of two tokens. Connected up to the SDK, the Frames SDK, so we could read the connected wallet address. That's already wired up through WAGMI hooks, so we can interact with that user's connected wallet. So we're using stuff like use account, wherever that is in here, use send transaction to view and interact with the user's connected wallet. And then most of the rest of this component is interacting with the 0x API to request price quotes, finalize those price quotes, get transaction call data, pass that back to the user's wallet. So we built out these couple API routes, one to get a price, one to get a quote, both of these interacting with the 0x swap API, and configured this component to hit that API when we enter a price. Oops. Maybe, oh, it's not running. or actually my 0x API key isn't in the environment, so these are going to fail. Hit that API, we get a price, and then finalize when we, when they click swap, get a finalized quote, pass that over to the user's wallet and execute it. This is up on my GitHub under my Horsebacks account as, what is this remote? Frames v2 swap demo. So you can find both this code and the live demo code that we did there. And there were a couple things that were slightly different. We added the external URL and a couple other things on the live demo that weren't in the other branch here. Okay, let's give this one more try on Vercel, and then I'm ready to give up. Finally. Okay, cool. I did not expect that to work. Awesome. Okay, so yeah, here we go. You can see we got swap ETH clanker in this embed. That is not API. That's this page here, /swap/page. Or yeah, the route here is this page.tsx, right? But the route is this /swap route, passing a query param, saying which token to use. And if we change this to USDC, now we'll get ETH USDC. I'm going to drop this in. Well, I'll drop it on Farcaster in a sec. I guess I'm logged in with my dev account here, so none of you will see it, even if I do. But yeah, there we go. So this sort of just to build the intuition here, this is what you can do to parameterize your frame by a different token or some different attribute that you want to parameterize it by. You could use a query parameter like this, whatever is a unique URL. Use a query parameter, use a route parameter, whatever you want. And when we tap this, it's going to open up to the route with that token pre-selected. So let's change this back to USDC. And we get USDC selected. So yeah, just the final note there is that embeds are really flexible, right? You define inline this configuration about your frame. It can be a different image. It can be a different button text. It can be a different URL for the action. You can even have different splash image and background color. This is super, super flexible within Frames v2. So you can have embeds anywhere in your web app that you want that are pointing to different routes within your frame application. So if you're thinking okay, does my does this route association, this home URL that's defined in your top level Farcaster.json file is basically just the fallback default, right? If you haven't defined this in an embed locally, and we can't find anything else, we're going to fall back to this as your default. But otherwise, these are super, super flexible. You can drop an embed basically anywhere on any URL, and if it has valid FC frame tags and this decodes to a valid frame configuration, you can set these however you want. So I know some people have thought okay, maybe there's one-to-one association. It has to be prefixed with frames. It has to be set up in this particular way, but actually it's extremely flexible. You can kind of configure these and drop these embeds wherever you want. And that means you can build a frames application, right, that has multiple frames, multiple entry points, multiple different embeds. They can be generated dynamically. You can do all kinds of stuff with this. So don't think that your frame embed has to match one-to-one with a route or has to be prefixed with anything in particular. Cool. Okay. Yeah, you can find this demo. This was fun. You can find this demo on GitHub in this Frames v2 swap demo repo. I may clean some of this up and push it up later. You can find this app. Yeah, it's linked here. If you drop this into Farcaster right now, this should show up. Maybe not pretty, but it should show up. I think I need to go add the 0x API key to the Vercel environment before it'll actually work, but you'll see the frame render and should see this work. We didn't edit the domain association here, and that's actually probably going to be invalid. I'm just realizing because we this is now hosted on a different domain, and so we just copy pasted my signature over the demo domain. So I'll need to go regenerate that, but we already have a video on that. I'm not gonna go over that right now. If you want to see that, go look on my earlier YouTube tutorial recordings for there's one that covers how to generate your domain association. And yeah, this was fun. Thanks for tuning in, everyone. See you on Farcaster.